In this video, we will look at some more of our properties of exponents, more specifically our zero exponent rule and our negative exponent rules. Let's start with the zero exponent rule. We learned that any base raised to the zero power will always equal 1. Now, we have two examples. Notice how in the first example, the negative 8y is inside parentheses. That means the whole entire base is the monomial negative 8y. So if that base is raised to the zero power, the answer is just 1. All right, let's take a look at the second example where there is no parentheses. Well, this answer is just negative 8. And the reason why is because only the variable y is the base. So only the variable y is being raised to the zero power. We need to look at those in a little more detail to make sure we really understand what's going on. Well, for the first one, there's really not much more to say. The whole entire base is negative 8y, and that's being raised to the zero power. So that's why it's just 1. Now, in the second example, where it's negative 8y to the zero power without parentheses, we need to think of this as the negative 8 being multiplied by the base of y, which is being raised to the zero power. So again, only y is being raised to the zero power. So this becomes negative 8 times 1, which is a final answer of negative 8. So you have to make sure you understand the difference between when there is parentheses around the whole entire base versus when there's no parentheses. That means only the variable touching the exponent is the base, and anything else gets multiplied afterwards. Let's look at our negative exponent rule. We learned that if we have a base raised to a negative exponent, it becomes the reciprocal of that base raised to the positive version of that exponent. So for 3 to the negative second, that becomes 1 over 9. Now, negative 3 to the negative second without parentheses can be also read as the opposite of 3 to the negative second power. So this is negative 1/9. And then the last one where the negative 3 is in parentheses, we would say negative 3 to the negative second power. This is positive 1/9. So notice our answers. We have a positive 1/9, then negative 1/9, then a positive 1/9. So we definitely need to look at these more in depth and make sure we understand how come some of these answers are positive and some of them are negative. So let's look at the basic one, 3 to the negative second power. The base is 3. So we take the reciprocal and we get 1 over 3 squared, which is 1 over 9, because 3 times 3 is 9. All right, let's look at the next one. The opposite of 3 to the negative second power. Since the base here is just 3, because there's no parentheses, we need to think of this as a negative 1 being multiplied by 3 to the negative second power. So we have negative 1 times 1 over 3 squared. And then that becomes negative 1 times 1/9, which gives us negative 1/9. All right, let's look at the last one. Now the negative 3 is in parentheses, so the base is negative 3. Let's go back really quick. Let's make sure we understand the first two answers. The first one is positive 1/9. The second one is negative 1/9. Okay, let's look at the third one. Now the negative 3 is in the parentheses, so the base is negative 3. So this becomes the reciprocal. So we have 1 over the base, which is negative 3, raised to the second power. So notice how I kept the parentheses in the denominator around the negative 3. Well, now I have 1 over negative 3 times negative 3. Because if I'm squaring negative 3, I'm going to arrive at a positive 9. But since it's in the denominator, I get an answer of 1/9, positive 1/9. Okay, let's look at some more negative exponent rules. Now I have 1 over b to the negative power of n. So now I still have a negative exponent, but now it's in the denominator. Well, that just becomes b to the power of n. And there's another rule we're going to look at. B to the negative m power over b to the negative n power becomes b to the positive nth power over b to the positive m power. You have to remember the key word here is reciprocal. So whenever you have negative exponents, all you're doing is you're taking the reciprocal of that quotient And when you take the reciprocal, the exponents become positive. So notice how the negative m power was in the numerator, and now the positive m power is in the denominator. Same thing with the n. We see that they switched places and went from negative to positive. Okay, let's look at 1 over 3 to the negative second power. According to the rule, that would just become 3 squared, or 9. And we'll look at that in a little bit more in depth in just a second. So let's look at it right now. So if I have 1 over 3 to the negative second power, I want to make sure we really understand this rule. I'm going to rewrite the number 1 in the numerator as 3 to the 0 power over 3 to the negative second. Now, 3 to the 0 power is equal to 1. So I can replace the 1 in the numerator with 3 to the 0. The reason I did that is to give me the same base. Now my numerator and denominator both have a base of 3. So now I can use the quotient rule, which tells me I take the numerator exponent and I subtract the denominator exponent. So this becomes 3 to the power of 0 minus negative 2. Be careful there. I have minus and then the negative 2. Well, we know that that becomes 0 plus 2. So this becomes 3 squared, or just 9. So that's why the rule works. All right, let's look at the second version, or the second rule. So if I have 3 to the negative fifth over 3 to the negative second, according to the rule, I just take the reciprocal. And when I do that, the negative 2 becomes positive 2, and the negative 5 becomes positive 5. So now I have 3 squared in the numerator over 3 to the fifth. Now, I can expand this. 3 squared becomes, whoops, I'm not going to expand it. We're going to use our quotient rule. Quotient rule tells me to take the numerator exponent minus the denominator exponent. So this becomes 3 to the power of 2 minus 5, which becomes 3 to the negative third power, and then I use my reciprocal. That becomes 1 over 3 to the third, and since 3 times 3 times 3 is 27, this becomes 1 over 27. Let's look at that in a different way. Let's say we don't want to take the reciprocal right away. Let's say we want to use our quotient rule, which tells us to subtract. So we're going to do 3 to the power of negative 5 minus negative 2. So again, you have to be careful. I'm subtracting a negative number. That becomes 3 to the negative 5 plus 2 power. Negative 5 plus 2 is negative 3, so that becomes 3 to the negative third power, which becomes 1 over 3 to the third. So there's my reciprocal, and that's 1 over 27, so I get the same result.